Today, Pete and I are going to check out the very rare Birdcage Corsair restoration project at Vultures Row Aviation in Cameron Park, California. It's been over 2.5 years since our last update, so it's time for an update. Let's go. If you wanted to choose a World War II Warbird to restore, you couldn't choose a more complicated project than a chance-bought Corsair. It's late December. We're back here at Chuck Wall's Vultures Row Aviation for a long overdue update on the ultra-rare Birdcage early model 1943 Corsair. There's several restorations going on at this shop at this time, and when this Corsair gets restored, it will be the world's only flying example of a Birdcage early model chance-bought Corsair. Update: this Birdcage Corsair, being such an early model, was a part of the, what was that, Chuck? Sikorsky, Vought Sikorsky aircraft company, and then Sikorsky and Vought and Chance split ways and it became Chance-Vought. Try to keep all that straight. This is so complicated, such a complicated story. Let's take a walk around the shop and see what it takes to get one of these aircraft restored. This is what makes a Birdcage Corsair a Birdcage Corsair. The canopy looks like a birdcage. The early model Corsairs had the pilot sit relatively low in the fuselage and had this birdcage style canopy for the canopy, somewhat limiting the pilot's view. Later models of the Corsair were modified where the pilot sat much higher in the cockpit, the tail wheel was extended, and the canopy was switched out to a bubble canopy, giving the pilot a much better view, especially when looking behind him. Here's a rare early model 2800 Pratt & Whitney engine that was used on the Birdcage Corsair. This engine was produced before they widely used water injection to increase the horsepower out of these engines for takeoff and at altitude, but this engine has a 2-speed mechanical blower. Technically it's a 3-speed mechanical blower that supercharges the air prior to entering the carburetor, giving you sea level or greater manifold pressure all the way up to a very high altitude. Once you achieved a certain altitude, say 16,000 feet, and your manifold pressure began to drop off, you would select the next higher stage of blower and maintain that manifold pressure up to the next higher altitude rating.
The engine shown here in Chuck's shop is just used for mock-up purpose. The actual engine for this restoration is being rebuilt by Anderson Aeromotive in Grangeville, Idaho. Of course, these cylinders have 2 rows, 9 cylinders of each row, 18 cylinders total, 36 spark plugs, and are rated at about 2,000 horsepower, slinging a 13-foot, 4-inch diameter Hamilton standard propeller, constant speed.
This is the incredibly complicated center section of a Birdcage Corsair. First, about the color. The salmon color is unique to the Birdcage Corsair. That's zinc chromate primer. Zinc chromate primer, as you typically know, is green. Well, on these aircraft, on all primers, it starts out as a yellow color. Then there's a second color added to it to identify that you have adequate coverage of your parts. That second color is typically zinc chromate green, that green color. In these early model Corsairs, they use this salmon color, the same as the t-shirt here, which you can get at the Vultures Row Aviation, to identify that they have had adequate coverage of the zinc chromate primer on this aircraft. Now the cooler to that engine, the blower to that engine required an intercooler system, and this is part of what gives the Corsair its distinctive whistling noise when it's diving. Air is brought in through the inlets here on the bent wing portion of the Corsair, and it is diverted two directions. One through the intercooler to cool the compressed air before it goes into the carburetor through a complicated system of plumbing, and another chunk of the air goes through the oil cooler, and all this air is exhausted overboard. Now, nothing is simple on a Corsair restoration. Everything is bent and tapered and twisted. The bent wing design of the Corsair makes this particular section exceptionally strong, but also exceptionally difficult to manufacture or restore. This is a double stretched section of aluminum that's 3 layers thick, riveted together, forming a 1/4 inch chunk of aluminum. Why has this got to be so strong? Because this is where the gear attaches. Why does the Corsair have a bent wing? Because it's got a 14-foot or so diameter propeller, and they're going to land this thing on an aircraft carrier, and they need a short, strong landing gear to absorb that punishment. So they created this inverted gull wing to make that design happen. That makes the designing of this center section incredibly complicated, starting all the way back to the main spar. Ahead of the cockpit is a main fuel tank between the firewall and the cockpit. These are clecos, or temporary fasteners, that are holding the skin on in place before the skin is riveted into position. This part will be replaced. Now Pete and I are going to take a look at the inside of this incredible center section. Chuck, all these ribs are going to be spot welded?
Yes.
Yeah, all of this material here has to be spot welded. What do you see over there, Pete?
A bunch of little scraps of...
Oh yeah, that's what those the filings from the drilling going on there. And right about over there should be about where the gear attaches. And this is the back side of the main spar. Yeah, all that will have to be cleaned out. So how do you know you're building your Corsair straight? Well, you got to jig the sub-assemblies. To make a jig for a Corsair, you start with a straight Corsair. You start with the actual airplane and then build a center section jig to match that original airplane. But you can't just weld the jig together. You got to use epoxy in the fine fit and finish of these parts here so that while you're welding the jig, it doesn't move. Let me show you. So here we have a bolt attach point for the jig, and right in here is where this jig component is floated with epoxy into the jig itself so that the jig does not move while it's being welded. There's no blueprint drawing for these jigs. You have to make the jig from the original aircraft. Without an original aircraft, you do not have a jig. Here at Vultures Row Aviation, Chuck has 4 of these center section jigs, a whole raft of wing jigs, and all the other jigs necessary to build the Corsair. To create the 4 center section jigs, he had to use the same aircraft to make all 4 center section jigs. Now let's take a look at the inside of the Birdcage Corsair cockpit. Remember, the Birdcage Corsair, the pilot sat lower in the aircraft than later model Corsairs, and so all of this equipment is a bit lower than later model Corsairs. Unique also to the Birdcage Corsair was this 100-pound bomb dropping mechanism. They apparently had a 100-pound bomb on each wing, and this was the mechanism that allowed you to drop those bombs. Yeah, you can see this. This is the mechanism you use to unlock the wings. This is the mechanism you use to fold the wings. Here's your elevator trim, rudder trim, aileron trim, and up here is your throttle quadrant. Throttle, mixture, prop, and I assume blower as well. And that blower had 3 positions: neutral, low, and high blower. Here's your flap indicator and lever. There's your magnetos, left, right, and both. Dive brake. The Corsair used the landing gear for the dive brake. Remember the big flat plate in front of the landing gear of the Corsair? That was your dive brake. So when you lowered the dive brake for bombing, you were lowering the main landing gear. The tail wheel remained retracted as it had a speed limit of about 200 knots. So when you went to land, you wanted to lower the gear with the landing gear, which lowered all 3 gear, and there's your position indicators. Over here we have the position of the intercooler doors and oil cooler doors mounted on the bottom forward of the aircraft, and then your standard instrument panel. Pete, what instrument's that right there? Knots, airspeed indicator. There's your artificial horizon. There's your World War II clock, cylinder head temperature, oil pressure, oil temperature, fuel gauges, volt, ammeter, altimeter, RPM, and look at that, a takeoff checklist right there. Gun switches off. In these early model Corsairs, there was also a window underneath your feet, basically, for bombing. This was removed in later model Corsairs because the Corsair was considered to be more of a fighter aircraft and less of a bombing run. Now here's some original Corsair parts, and of course it's pretty corroded over the years, but some of this, well, all of this is critical for pattern work. We'll explain more about how this all gets put together, but a lot of this can be reused as well. It'll be completely disassembled and the usable pieces pulled out of there and completely restored. After the cockpit is the midsection and the aft section, and that's what's in the jig here. So like any other aircraft build, you start with the bulkheads, the main bulkheads, get them in the jig, and then line up your longerons and the remaining bulkheads to line it all up. Back here in the aft section, a lot is going on. Back here we got the tail wheel assembly, the tail wheel doors, retractable tail wheel, the vertical tail and the horizontal tail all coming together back here. And of course each part gets smaller and smaller and harder to work with. And all compound curved. And don't forget the tail wheel hook is also part of this assembly. In order to do a job like this, you gotta have the original factory drawings, but that's not enough on its own, on itself, by itself. Your do-it-yourself Corsair kit, some assembly required. Welcome to the wing section of the assembly line. These are the outboard wings panels for the Birdcage Corsair. Let me show you a couple things that are unique to the Birdcage. On this wing section, the spar is new construction. A lot of the ribs are original construction, restored. And here's some original parts, some of which will be reused, some of which will be replaced. But it's in place right now just to get the layout for the wing right. The 350 caliber Browning machine guns, which exited through the leading edge through this piece here, were mounted in this bay right here. 3 ammo bays right here held over about 1,100 rounds of ammo and fed the 3 machine guns. Unique to the Birdcage Corsair was a fuel bay, a wet wing fuel bay just outside of the gun bay, located right about in this area here, which provided about a little over 53 gallons of fuel in each wing. Coupled together with the large fuel tank in the fuselage gave you, well, over 300 gallons of fuel. The early model Birdcage Corsairs did not use drop tanks. Once the tactical advantage of drop tanks was realized, this fuel bay was abandoned, this wet wing fuel bay was abandoned in later model Corsairs, and drop tanks were used instead, so that when you got into combat, if you needed the additional performance, you could pickle or drop those drop tanks and achieve a higher performance out of your aircraft, but a lot less range. So the idea was to hopefully not drop your drop tanks until you'd burned most of the fuel out of those tanks. A lot of the components on the Corsair got to be spot welded, and this is the spot welding machine. That's it. Done. All right, let me see if I can get this right. This spot welder is basically from World War II, but it's using modern computer technology over here. It takes a huge amount of current to plasticize and spot weld or resistance weld the point that you need to fasten together. About 25,000 to 35,000 amps for just a few milliseconds. And the Corsair is just full of these spot welds, and here's another example. He's got this piece spot welded initially, then he's got to take these ribs. They're going to cleco them into position here with these holes, the holes that he's drilled, and then he's got to put a series of spot welds in between here, remove the clecos, and then rivet the holes. Here's another example of the spot welding in this horizontal stabilizer skin. Here's the spot welds, and notice the blue rivets. All of the VOT rivets are anodized, blue anodized, for corrosion resistance in marine environments. Lots and lots of spot welding. And here's kind of where it all starts. Here's an original wing that's being slowly disassembled. All the components will be evaluated to see what stays and what goes. Here's the heat treating facility. A lot of the aluminum starts off as dead soft O aluminum and needs to be properly heat treated to get the proper hardness of the aluminum. So per the blueprint specs, it's heat treated using this process here. Heated in the oven and then quenched in the hog trough. A lot of the trick curves in a Corsair are stamped with this machine here. But before a part could be stamped, a whole series of events has to take place first. Here's one of the relatively easier parts of the Corsair, the horizontal tails, which are interchangeable. But the spar to the horizontal tail is an example of a part that needs to be stamped out. It's got this tapered curve joggle to it. So how do you get a stamped piece of aluminum created for a Corsair from a set of original blueprint drawings? Well, you start with the blueprint drawings, but then you take that blueprint drawing and an actual component from the aircraft and together model that with a modern computer CAD program and or SolidWorks. And from SolidWorks, then you can mill an aluminum die for the part that you need to stamp, and then you can put this stamp or this die plus the aluminum in the big blue stamping machine. Kablamo, you got the part. If you're going to make one part, you might as well make a whole bunch of them. So in order to do that, you're also going to need a milling machine. Is this a 3-axis milling machine? 4-axis milling machine to make the aluminum dies for the stamps.
So from the SolidWorks modeling, the data is put into a second program called SurfCam to create the data to feed to the milling machine. And here's the 4-axis milling machine making the die. Pete, what did you find?
Fridge.
The fridge? What was in the fridge? What'd you find? A cookie.
So you got a lot of compound curves that need to be fastened together on the Corsair. A lot of it is riveted conventionally, a lot of it is spot welded, but what do you do when it comes to a blind rivet? A rivet operation requires that you get a hold of both ends of the rivet. You buck it and rivet it from two different ends. What if you get into one of these complicated parts that has a channel but you can't get to the other end? Well, Chance Vought did not use Cherry Max or blind rivets. I don't even know if Cherry Max was invented at the time of these early model Corsairs, so they had to use a technique called an exploding rivet. Check this out. Correction, it's not an exploding rivet, it's an explosive rivet. So let's check out how this explosive rivet works. This is an explosive rivet. The charge is located right up in there, and these are World War II vintage rivets. And here at Vultures Row, he's got thousands of these surplus rivets.
Hold your ears, Pete. He's gonna put the heat to it. Ha ha! This is like a pop gun. Wow.
Yep.
Just that easy. Here's another very complicated compound curve, the trailing edge of the wing where the flaps are going to retract into here.
This compound edge needs to be spot welded all along there.
In order to do that, you got to form it in these jigs. Once that trailing edge is spot welded, it's set. Like we talked about in the last update, the mag wheels, the original magnesium wheels, are being replaced by these new aluminum wheels, much stronger. Restored landing gear parts, and if any component is found to be unairworthy, it can still be donated to a museum for a static display.
Balls.
The nose bowl or leading edge of the cowling piece is especially troublesome. Double compound curved piece takes a lot of different strategies to get this metal formed to this shape. So there's enough for about 5 nose bowls right there. Here's a dash 4 mid section and tail section that's getting a unique treatment to it. The dash 4 is the late model Corsair. This one is going to have a jump seat or a rear seat. It will not have dual controls, but it will have a back seat capability, so they're going to create a couple of windows back here for the passenger. And no, they will not be selling rides.
Bonus round footage for all you air race fans. This is Cook Cleland's air race plane, a A1, is that correct? A 1A model Corsair. Cook Cleland raced this in the 1946 Cleveland National Championship air races as the Lucky Gallon. That is the original paint back there on the back of the aircraft. I'll show you a photograph of it in its racing configuration. So this being a 2800 powered Corsair, Cook came in 6th place in the 1946 air races. He went back to a Navy admiral and said, I need a faster airplane, where he picked up then the Super Corsairs, the 4360 powered Corsairs, and then went on to race those aircraft.
Much of this historic aircraft was found in a basement on an estate sale in the Midwest.
So I want to thank Chuck Wall and the staff here at Vultures Row Aviation for another fantastic tour of the facility. I got to get back here more often for more frequent updates. Chuck, we can expect to see a Birdcage Corsair on its gear in about
a year and a quarter.
About a year and a quarter. So stay tuned here for an update. We'll have another Corsair in the shop here sooner than that. That's what some of these components are for. Stay tuned for that as well. See you here. Thanks so much for your support of this channel and for those over on Patreon that make this content possible. See you here.